Welcome to Click for IB Biology. We are studying topic D4.3 climate change, and in this particular video we're going to be looking at how global warming itself is the result of positive feedback mechanisms and its impact on ocean currents. There's a version of this presentation, a blank PDF, that you can download from the description. It's linked in down below the video, and you can annotate that with your own notes. At the end, take the 10-question quiz and check out with the answers to evaluate the learning that you have achieved. So let's take a look at this concept of a positive feedback within the process of global warming. So we may be more familiar, in fact, with negative feedback systems which have a regulated fixed point in which, as the variable increases, there are correcting mechanisms that bring this back into line with the fixed point. And indeed, if we undershoot the fixed point, there are other feedback mechanisms which correct and bring us back to the fixed point level, like so, and that the idea is to minimize the disruption or the disturbance from the fixed point level. And the less disturbance, the more stable and constant that condition is. However, in a positive feedback mechanism, positive feedback loop, there is an action or the stimulus which leads to a response, but rather than moderating the action or stimulus, what happens is there's an enhancement or an increase, if you prefer, and we can illustrate that with this graph here. So over time, as the action or the stimulus returns through the system's response is to actually bring about an increase. And so you can see that this upward pointing curve shows an increase in an aspect of the climate over time as a consequence. So the factor is feeding back and enhancing and increasing that influence. Within climate studies, one of the concerns is that there may be, in fact, within this curve, what we might call tipping points. And these tipping points are critical values of the system, such as carbon dioxide levels or temperatures, and they result in a sudden acceleration even beyond the projected positive feedback levels, and the system may become increasingly under control. And currently within discussion on this particular issue is the decline in the surface area of the ice shelves, which seem to be decreasing faster than we expect. So we may have already reached a tipping point within global warming, which, with respect to the ice fields of both the Arctic and Antarctic regions. Let's take a look at a model of these positive feedback effects. Not ordinarily light shining onto the ice and snow areas, particularly of polar regions, of the Antarctic regions, but also of the mountainous areas of the world. Light will hit the snow fields and the glacial fields, and much of it will be reflected. However, with an increase in the production of greenhouse gases, and in particular here we're thinking about carbon dioxide, the impact is something different. Light striking the ground, the light energy is turned into infrared energy, and that is radiated out towards space, and indeed much of it does indeed escape to space. However, carbon dioxide is one of those greenhouse gases which will absorb the infrared light and then will re-emit it from the movement of the gas. This increase in the kinetic energy of the gas particles of the atmosphere, of course, is measured by temperature, and so we experience temperature increases. In turn, those temperature increases are associated with an increased melting of the ice and snow caps of the polar and Antarctic regions and the mountainous regions of the world. And this melting process reveals more and more ground, more and more darker ground, which will absorb the light rather than reflecting the light. This is called the albedo effect and is an example of positive feedback in which the melting of the ice accelerates the production of the darkened ground, which increases the reflection of infrared radiation into the atmosphere. And of course, that leads to an acceleration of temperature increases, which in turn leads to more ice melting. And so, as mentioned previously, we're into a positive feedback cycle. These positive feedbacks affect not just the polar ice caps, but also areas associated such as the Tundra regions with its peats. The melting of snow, the rapid melting of snow and higher temperatures result in peat areas increasing their decomposition and the release of carbon dioxide and methane gases from those areas. And then there's also a complex interaction with oceans, in which, in the first instance, the increased temperature of the oceans absorbing these increases in temperature, are unable to support so much carbon dioxide solution and the release of carbon dioxide to the atmosphere, again with a further positive feedback influence on the atmospheric carbon dioxide. There is a secondary effect with the increasing carbon dioxides, and that is that, as previously mentioned in the first video, the oceans are associated with about 27% absorption of the extra greenhouse gases emitted by humans, and this leads to a process called acidification. And whilst not immediately part of the global warming issue, is another major impact of global warming on the environment. The increase in the temperature of the ocean leads to a disruption in two aspects of those oceans. There's the ocean currents and then the mixing of the oceans. Now, of course, the basic concept is that cold water is dense and sinks, and hot water is less dense and rises. And so when we look at the world's major oceans, there is something of a conveyor belt is described, the flow of water around the world's oceans in continuous ocean currents, in which water is sinking in the poles and rising in the tropical regions. As the water is warmed in the tropical regions, it rises, but sinks in the polar regions as it cools. Now, of course, if we increase the atmospheric temperatures, then we will disrupt these cooling processes, and the normal circulation, as can be shown here in this diagram, becomes disrupted. At various locations around the world, the upwelling of water from the oceanic deeps brings with it large levels of nutrients, and those nutrients are important in terms of phosphates and nitrates for phytoplankton, which through their photosynthesis create the producer levels within our communities, which support the food chains and the oceanic food webs. And so by disrupting the atmospheric temperatures, we disrupt the oceanic conveyor belt of currents, we disrupt the mixing processes of the ocean layers, and therefore we undermine and prevent the phytoplankton communities for their increased biomass production and in turn this undermines the communities of organisms within the marine ecosystems, some of which we'll be taking a look at in later videos within this particular channel. In the next video, we're going to look at the effect of disrupted ocean currents on animal distribution. There's a chance to subscribe to the channel. The playlist is on the right. Thank you very much for subscribing.